Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, what I will be presenting tonight will be a discussion on how install the power supply of my 6-digit digital clock. The power requirement of this digital clock is actually 5 volts. So it's a must that we should input a voltage to the input terminals to be 5 volts. So what I did, guys, is I got a voltage regulator L7805. L7805, that's the pin out. Terminal number 1 is the input. Terminal number 3 is the output. The middle terminal is the ground. The specification of this L7805, if we try to bring out a 5 volt steady output, it will be in the range 7 volt to 35 volts. Meaning to say, if you input is 7 volts here, the output will be 5 volts. Any value between 7 and 25, it will output a steady voltage of 5 volts. So this is what we need for this 6-digit digital clock. And what I did, I got an adapter, an old adapter of my cell phone. The output of this one is actually 6 volts, 8 volts DC. 8 volts DC. So this is just good enough to use as the power input of the voltage regulator. So the connection is actually at the back. Okay. This is terminal number 1. This is the ground, the middle terminal. The third terminal is the output. So the output should be the one coming from the LED clock. So these are the terminals. The upper one is actually the plus. Sorry guys, I don't have a red wire. I just use both white. Anyway, this is intact already, so I will not be interchanging the polarity, you know. The top one is the plus, and the bottom one is the minus, meaning the ground. So the ground is connected to the middle terminal. If we go back to the circuit, the ground for both the input and the output are actually common. So I merge the ground for the input and output. I solder it on the middle terminal. Okay, and the plus terminal on the adapter, okay, it should be connected to terminal number 1. This one, the one with the red heat shrink tubing. This is terminal number 1. Actually, that's the, what they call this, L7805. I screwed it upside down. Anyway, this is not so hot because the current is not so much. It will not burn this wood here. This is the heatsink. So this is terminal number 1. This is the voltage input coming from the adapter. And the output is actually terminal number 3, the one with the black heat shrink tubing. This is the one that goes to the plus of the digital clock, the top one. So this top one here, top line, is connected to this black heat shrink tubing. And that's the output of the L7805. It's 5 volts. So we input an 8 volts between ground and this red thing here. And what will come out if we try to use the 7805 will be 5 volts between ground and this black thing here. So right now, the input to this digital clock is actually 5 volts and it looks good. Okay, it looks good. And for us not to interchange the connection, I make it a a steady one now. What do you call this? I tied the terminal of the adapter back here. So while we are moving this one, we will not be interchanging anything. So it's just like this, guys. Okay. Okay. That's the clock. That's the adapter powering up the L7805. And the output of the L7805 is actually 5 volts. So the one entering here now is actually the output of the L7805, which is 5 volts. This is 5 volts. It is marked 5 volts. See? Okay. So this is a good accomplishment for tonight because last night I did the assembly and I ran it for quite some time, but I just would like that I will be using this digital clock on my table. So I made a, what you call this, a steady power supply for this one. It is an old adapter of my old cell phone, Nokia, the old one, you know. The output of this one is actually 8 volts. Okay. That will be the input of the L7805, 8 volts. So if we try to use 7805, that 05 refers to 5 volts. It will come out 5 volts. So right now, the input voltage of this 6-digit digital clock is actually 5 volts. And it's working fine. And it's easy to adjust. The adjustment for the hour is this one. For the minute is this one. No programming required. For the second, it will just follow. Okay? So once you enter this is military time. This is almost, if we subtract this one by 12, is actually this is 12, it's 10:35 p.m. MD. But militarily speaking, this is 22 hours, 35 minutes, 41 seconds. Okay, that's it, guys. This is another good accomplishment of Professor David J. De Los Reyes because I assembled this kit myself. Then I made the power supply of this one by using my knowledge of the, what they call this, construction of voltage regulator. Okay. That's L7805. Okay. That's it, guys. Good evening from Los Angeles. This is an assembled 6-digit digital clock done by yours truly, Professor David J. De Los Reyes. Then I installed the required 5-volt power supply by using an L7805. And the input to the L7805 is an adapter from my old cell phone. Okay. So this is very handy. Okay. This is very handy. So if ever you transfer this one from one place to another, you could transfer it. You just remove this one, put it on your table maybe, plug it in, then punch in the time. It's just like that. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes.